This is RD Sharma solution. We are taking chapter 17 of class 12th increasing and decreasing function. Exercise is 17.2. Find the interval in which the following function are increasing or decreasing. So this fx is equal to 5x raised 3 by 2 minus 3x raised 5 by 2. X is greater than 0. So first we'll differentiate it. F dash x is equal to what? It's 5. This 3 by 2 comes here. X to the power 3 by 2 minus 1. This is minus 3. 5 by 2. X raised to the power 5 by 2 minus 1. So this is just simple differentiation. What is 3 by 2 minus 1? It's 3 minus 2 by 1, that is 1 by 2. And anything raised to power 1 by 2 is under root. So x raised half. And what about this one? This is 15 by 2. 5 by 2 minus 1 is 5 minus 2 by 2. That is 3 by 2. So this is x raised 3 by 2. So 3 by 2 is what? 1 plus 1 by 2. And when it is in the power, you can just write x into x to the power half. X raised 3 by 2 I have written like this. Now x raised half is there and 15 by 2 is also there common. So you can take 15 by 2 x raised half common. You'll get 1 minus this, you can just eliminate. Only x will remain. Now this f dash x will give you the critical points or the intervals where the function may be increasing or decreasing. So you just have to put it as 0 and find out where it is going to be 0. That is the point where it is changing its direction to increasing or decreasing. You know that x raised half, that is under root x equals to 0, that is x equals to 0. 1 minus x equals to 0 is equal to x, that is x equals to 1. So x equals to 0 and x equals to 1, these are two critical points. So we'll go ahead with 0 and 1. Now this is the number line. If I want to represent this is 0, this is 1. This is negative infinity, this is positive infinity. So we have to include 0 and 1 because we have got these two as the critical points. In increasing, f dash x should be greater than 0. So it should be 15 by 2 x raised half 1 minus x greater than 0. Now what does it mean? See, under root x raised half is nothing but under root x. And under root x means always positive. You cannot have a negative value. So it will always be greater than 0. 1 minus x greater than 0, that is 1 minus x greater than 0, this x is less than 1. That is under root x into 1 minus x greater than 0 just simply means both of them should be greater than 0, both of them should be less than 0. But under root x will always be greater than 0. So only 1 minus x greater than 0 is the main key. So this it has to be x less than 1. From here we got x less than 1. Again, let me tell you again, under root x cannot be negative or less than 0. So whichever thing is inside under root, it should always be greater than 0. So this x belongs to 0 and 1. 0 comma 1, because x is greater than 0, x less than 1. That means the common point is x between 0 and 1. This is f dash x greater than 0. Now coming to the next point, which is f dash x less than 0. So less than 0 means just put it as 0 less than 0. So 15 by 2 x raised half 1 minus x less than 0. Again under root x raised half, it cannot be less than 0. Only 1 minus x can be less than 0 because x is always in under root x should always be greater than 0. It is always positive. 1 minus x is less than 0. That is x should be greater than 1. So if x is greater than 0, x is greater than 1, what does it mean? It means what? It means x should be greater than 1. So what will be the solution here? X belongs to 1 to positive infinite. This is the answer. So this is minus plus minus where it is increasing or decreasing. Increasing we put plus, decreasing we put negative or minus. So this is the reference solution that you can follow in order to solve it and write it. And those who want to do by themselves, they can also do it like this. The making of diagram is very essential in these questions. Okay, please note this. We'll go ahead now. Find the interval in which the following function are increasing or decreasing. So we have f dash x will find out. So let us find it directly. 8x to the power 7 plus this 6 to the 12 x. Now you can take this x outside. You will get x raised 6 here. Here 1. Now when you take 4 outside. 4 to the 8, 4 to the 12. So when you take 4 outside. So you have taken essentially 4x outside. So inside what will be remaining? Here 2, here 3. So 2x raised 6 plus 3 and 4x. So now let me tell you about the critical points. When critical points are achieved when we put this as 0, this expression as 0. So either x is equal to 0 or 2x raised 6 plus 3 is equal to 0. So x raised 6 equals minus 3 by 2. Now this cannot happen. X raised 6 equals negative 3 by 2 is impossible. How? X raised 6 is nothing but x square to the power 3. X square cannot be negative at any cost. Whatever you put here, either negative or positive, it will always be positive. So you do cube or any number in that power, it will always be positive. So you just have one point, which is x equals to 0. So there is only one critical point in this question, which is x is equal to 0. So anything which is greater than 0 to infinite will be 1 increasing, and 0 to negative infinity it will be increasing. I will see where it is increasing, where it is decreasing. So in this, f dash x greater than 0. So this is 4x, 2x raised 6 plus 3 greater than 0, and I told you about this one, so you just forget about this. It should be x greater than 0. So anything which is greater than 0 belongs to 0 to infinite. So x should belongs to 0 to infinite is one case. Now f dash x is less than 0. Same concept we are going to follow here, and f dash x is less than 0. Again I told you that x raised 6 equals to negative 3 by 2 is impossible. So anything on the right which is negative cannot have on the left as square power. So only x should be less than 0. Anything which is less than 0 goes from 0 to till end, and what is the end? It is negative infinity. So negative infinity to 0 is the interval where it is decreasing. This concept I already told you. So this is the only catch in this question. Otherwise, you know it already. Now let me show you the reference here. The thing which I explained you has to be very clear. X square cannot be negative. That is why the final result which we got is 0 to infinity and negative infinity to 0. So this is increasing point and the other one was decreasing point. Now this x cube question we have already done. So we'll just go ahead with this and we'll pass this question, because these questions has been attempted and being solved a multiple number of times. There is no difference. The procedure will remain the same. There will be no difference here. So this question also is similar, but this kind of question can come in your exam, because normally the examiner or the paper would make certain questions bit tricky. So if you have done your mathematics properly, then only you will be able to attempt it. So this is only one step away from what we have been doing. You just have to multiply this. That is x into x minus 2 whole square. Just have to multiply this. So multiply this x into x minus 2 inside first. You will get x square minus 2x, and then you square it. So a minus b whole square. You will get a square plus b square minus 2ab. This is simply a square minus b square, a square plus b square minus 2ab. So x raised 4, and this is 2ab, 4x square plus, and 2x whole square is what? It is 4x square. 4x cube, sorry. So a square plus b square, 2x whole square is 4x square. So that we have already done. F dash x now. Now I am just differentiating it. So it will be 4x raised 4 is 4x cube. So this is 4x cube. This is 8. 4 to the 8, 8x minus 4 to the 12x square. So this is simple differentiation which we have done. And there are things which we can take outside so that we can make proper roots here or the factors here. So I'm taking 4x outside, it will be x square inside, and I'm just swapping these two to make it the way we are used to see it. X square minus 3x plus 2 minus 3x can be achieved from 1 and 2, which is already there. So x square minus x minus 2x plus 2. You can take x common, x minus 2, you can take minus 2 common, x minus 1. So you have 4x, x minus 1 into x minus 2. So this x into x minus 1 into x minus 2. So when you put this equal to 0, you will get the critical point. So x should be equal to 0. X minus 1 equals to 0, that is x equals to 1. X minus 2 equals to 0 means x equals to 2. So these are the three critical points. So how many intervals you will get? Because it will start from negative infinity, it will go up to positive infinity. These are the different sets or interval which we need to follow. The negative infinity to plus infinity, what are the interval? Minus infinity to 0, 0 to 1, 1 to 2, and then 2 to infinite. So 1, 2, 3, 4. 4 intervals we have got here. And you can also write in your solution like this, that we have got 4 intervals, because 0, 1, 2 were our critical point. So these are the 4 intervals which I have written. You should also write this. Next thing is f dash x. We are differentiating it. So f dash x should be greater than 0. That is 4 into x minus 1 into x minus 2 should be greater than 0. So I told you already, if you have 3 terms or 3 factors, both sides you divide by 4. So 4 will get eliminated anyways. So you have to talk about x into x minus 1 into x minus 2. When these 3 terms, 3 factors, when we multiply, so there will be certain combination, permutation, where it is going to be greater than 0. So I told you anything on the right from the last factor, that is 2 to infinite, and on the left 2 normal values which you got, that is 0 to 1 is one of the point or interval, and 2 to infinite should be the other point or other interval where you can just take the union. How about f dash x less than 0? Same thing has to be done leftwise. That is, negative infinity to 0 has to be taken and 1 to 2 should be taken. This way you will get to know if you practice it more. That is, 0 to infinity, negative infinity on the left, and on the right you don't have to go to infinity, leaving infinity first interval, which is the first interval from the right. It's 1 to 2. So the leftmost interval and this 1 to 2. This is the answer. And how you're going to go about it. So these are the references for you. Again, this question, again, we have already done like this. So I'll leave you with the reference so that you can try it out by yourself. And there are various questions which are coming which are almost like this. So I'm just skipping those until a question which has some explanation or something different which we can follow. Here also, the denominator question we have already seen. Just remove this 2. It will be a normal expression which you just have witnessed in the previous discussions. So these are 3 factors and you know how to solve this. We have just completed one question with these 3 factors. So right, this question is somewhat different. So we'll just attempt this. So first thing is f dash x. Log 2 plus x is 1 by 2 plus x. Differentiation of 2 plus x is going to be 1 only. Then you have minus this 2x divided by 2 plus x. So I'm using the quotient rule here, 2 plus x whole square. Now 2 plus x in the numerator now, and differentiation of 2x is 2. Now 2x here and differentiation of 2 plus x. Differentiation of 2 plus x is going to be 1. So 2x into 1 again. So what do you get when you multiply the numerator here? So this is 2 to the 4 plus 2x minus 2x. So this 2x gets cancelled. So you will get finally 1 by 2 plus x minus 4 divided by 2 plus x whole square. So how are you going to solve this? See, we'll take 1 by 2 plus x common here. You'll get 1 minus 4 divided by 2 plus x, and when you solve this, you'll get 2 plus x minus 4 divided by 2 plus x. So this is 2 minus 4 is negative 2, x minus 2 divided by 2 plus x. So x minus 2 by 2 plus x, and outside you have 1 by 2 plus x. Finally, you'll get x minus 2 divided by 2 plus x into 2 plus x, which is 2 plus x whole square. Now this is the f dash x. So if it is equal to 0, then you will get the critical point. Please remember, x plus 2 in the denominator cannot be equal to 0. You cannot have anything in the denominator 0. So only x plus 2 should be equal to 0, x minus 2 should be equal to 0. That will give you x equals to 2. Denominator x cannot be negative 2. First thing you have to be very careful about. And second thing, x minus 2 has to be equal to 0 for the critical point. Of course, we'll see this f dash x where it should be greater than 0. So we just have one critical point. What is the critical point? I'm writing 0, but you don't consider that thing. I'm just marking it for the sake of convenience. Otherwise, we just have a 1 point 2. So anything greater than 2 to infinity, anything less than 2 to negative infinity, that is on left and right, that is the point where it is increasing or decreasing. So we have f dash x greater than 0. That means x minus 2 divided by x plus 2 whole square should be greater than 0. There is x minus 2 should be greater than 0. You just forget about this, because if you multiply both sides by x plus 2 whole square, you are going to get 0 anyways. So x should be greater than 2. Anything which is greater than 2, that means 2 to infinite. How about f dash x less than 0? X minus 2, x plus 2 square less than 0. So it should be less than 0. So x should be less than 2. So x greater than 2 is from 2 to infinite. X less than 2 means negative infinite to 2. So increasing here in the 2 to infinity interval, and this infinite to 2 in this interval. So this is the whole scenario here, and this is the reference which you can follow. And these all you have to write, because everything has to be written so that the examiner can understand. So the next coming question are running question, and we are going to take it in the next discussion. Till then, thank you so much and take care of yourself.